So now you all my name, but what's probably puzzling you is the nature of my game. So now we are going to, together with Ehsan, we are going to be talking about the work we are doing together with companies in CERT. And we are going to be talking about asset management and technical debt benchmarking. So I'm Javier. As I said, I'm assistant professor in BTH. I have more than 10 years of experience in industry. So I have been sitting where you sit every day for more than 10 years. And then I decided to go back to academia and I did my PhD. I see myself as, I don't know if more a practitioner than a researcher. I mean, combination of both. And I collaborate doing research with Ericsson, Spotify, Fort Knox, that is not now saying yes, Volvo Construction Equipment, Swedbank, and others, right? And now, Ehsan?
Hi, I'm Ehsan. I have met some of you. I'm a PhD student at BTH. I work with mainly Javier. And on the topic of asset management, asset degradation, and of course, technical debt. I haven't had that much of an industrial experience, just here and there with some startups. But in that case, I would be a more pure scientist rather than Javier. But yeah, Javier.
Yeah. So Yerix has started today talking about SIPs and also has been talking a lot about being fast, right? So, and I want to go back to this analogy of SIPs. So have you ever seen a cargo ship, right? It's not brighty. It's not, so even the containers, everything is rusty, right? And if we own a ship, we might think that, oh, I don't want the ship to have rust. But does all rust matter? Is all equally painful? Is it worth spending effort in painting the anchor every week? Well, I wouldn't matter if the anchor is rusty. The second I see rust on the engine, I will start running, right? Also, Eric has been talking a bit about being fast. Few years back, somebody said, so systems change continuously because customers are not satisfied and which need to change them. And if we change them and we don't make anything to prevent it, they will degrade, the quality will decline. This was enunciated in 79 and Lehman's, and is something we continue suffering from it. So, and one of the fundamental problems we have is that we talk a lot about TD. Have you ever seen it? It's plenty of myths and misunderstandings about it. And what happens if somebody tells you, as tools say, you have 10,000 years of technical debt in your system? Well, I don't know. It's like you are driving your car, you bring it to service, and they say you have 10,000 problems in the software that is tracking your car. Well, that sounds scary. But what happens if it turns out that last year you have 9,999 problems, and this year you have 10,000? Nothing really, right? So we tend to quantify TD without thinking where the damn pain is. So TD is preventing us from being fast. But where is that important TD that is preventing us to be fast? How can we prioritize that? And what can we do about it? It's not refactoring the whole architecture and make it clean in 2 weekends. What is going to make us faster is go into the pain and fix it. And sometimes the fixture is not on the code, is outside in the real world. by rearranging, for example, teams or ownership, what will make us faster, instead of having one team having to approve every PR. Moving or transferring that ownership to the right team will make it much faster. And then it's not a technical solution, it's an organizational solution. And that's what I'm going to be talking about now.
Is that moving?
No.
Wait.
It's probably, can you touch the presentation?
Where is it? I can see the mouse. Oh, yeah, just touch. Okay.
So I'm going to be talking a bit about assets to try to move the mindset out of TD, although we will use TD. So we will do some magic to use it. And what can we do to fight against it, not only by spending 2 weekends or 2 years trying to refactor in a monolithic architecture, right? So, as I said, what does it mean that we have 10,000 years? Everything counts equally? Most likely not. So one of the problems we also have is that we tend to focus only on source code. But it's not only that. What happens if I do something on code that is not doesn't have a real bad effect on the code, but is creating problems, real ones, on the test base? For example, deprecating code might seem a good solution. I deprecate this version of the library. I put it on a side. It needs to be there for backward compatibility. And when you are typing code, you see deprecated function, and then you don't use it in the code. But you have 220,000 integration tests written in XML, in which you make calls to create the data to test it. And there is not visible that you have deprecated a version. And then somebody comes, creates a new test, and adds the same version of the deprecated code again and again and again. And a solution that didn't have an impact on the code turns out that it's degrading our test base. And all of a sudden you say, yeah, we need to remove this deprecated code. And then you have real pain fixing the test base. And this is something we don't consider per se when we work with technical debt tools, right? And again, I mean, if we look at what we do in academia, we measure what we know well. Measuring TD at code level is easy. Measuring whether or not a class is big is measuring the lines of code. That's easy. Measuring the impact of that deprecation in the test base is pain for us. And that's why we focus more in code. But that's what the barrier we want to break, and stop talking about TD only in code, but talking about assets and talking about how they degrade. So when we go to organizations, and this is actually something coming from a big organization, go into a meeting and 10 developers get out of the meeting room and they see technical debt are fighting. And it's like, yeah, you need to be doing this. We have a lot of TD here. Is that, what does it mean? So what do we mean? And if we start asking here, what's TD? And we have done it with organizations. If we are 20 people in the room, we have 30 definitions for TD, right? And then we need to do something about it, right? So, and as I said at the beginning, TD is TD. I mean, technical debt is 10 years of technical debt in your code. And then somebody asks, I don't understand why we are so slow. Basic, right? So, and we start discussing about suboptimal design decisions. So what? I mean, sometimes we do things and there are alternatives, but you don't have the ability to judge the long-term perspective because you don't see what's going to happen in 10 years. There are strategical decisions that were took because that was the best solution at that time. But now we know that they were not that good. So we want to move away from this. And we talk about assets. Assets is everything that is persistent in your organization, and it has value for you. If this integration test, this XML file, is important for you because you have 200,000 and now one from them, then that's your asset, your relevant asset. It's code and integration tests. And then that's what we need to focus. Assets have value for organizations. Not every organization have the same set of assets that are valuable. And then assets degrade. And assets, I mean, we don't even need to take a decision to make it degrade. Because we are changing and we want to be fast, it will get rusty. And we need to do something about it. Just by manipulating the assets, they will degrade. And the other problem we have is what I tried to explain with this code to integrations tests. I do something here and it has an impact there. And for example, we are working with a big organization about this concept of requirements depth or bad requirements. I mean, fixing a requirement, how long can it take? 3 afternoons of meetings, discussing and refining the requirement? Then we studied what happens if you receive a bad requirements with not a proper user interface mockup, not a proper description of the actions you need to take, etc. We measured the downstream consequences that it has. Ready to develop, back to refinement, ready to develop, on testing, back to ready to develop, back to, and it's insane. It has real consequences. So why do we all only look at code when the pain might be on requirements, right? And as I said, we want to move away from the technical depth concept or buzzword. But we still think that sometimes it's a good idea to use it as yet another way of measuring or understanding degradation. So, okay, you have today 10 years of technical depth, and 1 month later, you have 11 years. We are doing something wrong. So we see that what we call trends of TD. And that can help us to understand what's happening. And what's happening is not that we are stupid, because none of us are. Perhaps the problem is another place. Do we have the competence to maintain the system, or the competence is elsewhere in the organization? Are we just gatekeepers approving pull requests and the competence is elsewhere? That kind of things can make us accumulate TD much faster. And the solutions might be easier than refactoring that year of technical debt, but say, look, from tomorrow on, you are the one who approve pull requests, and we are the one that develop the thing, or the other way around, right? So sometimes the solution is not just technical, it's organizational. And now Ehsan will show the magic.
Okay.
He's the guy who knows.
Well, thank you, Javier. I think Javier covered almost all of the ground for what we are doing. And now it's time for you, okay, to ask, so what question? We are always talking about the concepts, but what we can do actually right now with the things that we have. And that's what I'm going to talk about. And the first thing is, I'm going to go back to the ship metaphor that we had from the beginning. So what we want to do is to pay the debt that actually matters. The debt that we have on the engine, we want to fix the rusty engine. But the first step would be for us to identify the rust in the engine before starting to fix it or finding the solutions. That's also what we are trying to do. First, our job is to identify the engine, what we call, or the pain on the engine, what we call the pain. We address the problem, and then we evaluate our approach, because more often than not, these problems are very case specific. It depends on the company and the system. Today, I'm mostly going to talk about the identification part and how we try to address some of them, and then our general plan. So what we do for identifying the pain, we look at the two main things, which are hotspots and change coherence. For hotspots, we look at the change frequency and complexity. But what are these? So a change, if you take a look at the file history and how many revisions you have for it, and you sort them out in a graph, you see that there are a few files that you touch more often than the others. So those files are more important for you. If there's a problem, it's better to start fixing something over there. We combine that with the complexity. If the same files that are changed more frequently also increase in complexity, that's already a bad sign. Something is changing a lot. We are making changes, and then it's also rising with the complexity. That's what we call a hotspot. If we visualize these hotspots in a system, we see that there are only a few really red ones that are good candidates for us to start looking at. At this point, we can't still be sure that they are the real thing, but it's at least a good indication. What we also do is we look at the change cohesion. So change cohesion is the number of times two files or some files change together. Some of the changes are expected. For example, if you have a class, you expect that to change with the test cases that are related to it. If they are physically located together, you expect them to change together. It is expected. However, if we look at real systems, we see that, oh, there are sometimes files that change together from other side of the system where they are not supposed to change. And that might raise an alarm. Still, okay, if this is a hotspot, it's changing a lot, and it's also changing all the way from the other side of the system, and you don't know why. That's another indicator for us. However, again, this is still done. There are metrics and tools that you can already detect this. We still have the so what question, and does it really matter to know this? What we want to do is look at the whole system, because systems are not generally one component, one repository, and if you try to represent them in graph, you end up with such a blob. What we want to do is to take a look at change frequency and change cohesion, and outside of the a single repository and go to repository level. And the metrics and the tools that we already have, and the ones that I even showed you, focus on one repository. So what about all these things that are outside of it? So we want to see the whole system in a new view. Here in this representation, if I may come here, the dots that you see are repositories or components. The size of the dot represents the number of changes that that repository has. And the links between them are the number of changes that the repositories have on them together. For example, if you have a ticket that involves touching two repositories, that is one case for us, or the same goes for a user story. And you can see that, for example, this big one here is changing quite often with this one here. So that's why the line is thicker. So the next question is the red dot, is the big red node the most problematic? Is it? If so, where is the problem coming from? And even after that, is there an explanation for that? Because knowing the context of what's going around the system or the component is also very crucial. And again, the question comes here, where should we start? Let's say that we identified that this is a problem. How can we start to really fix it? Now I'm going to link this to technical debt. we can visualize technical debt for all of the repositories and try to plot them and say, okay, these are the repositories that we are looking at. The bigger the dot, the bigger the technical debt that you have. But still, we also want to say, okay, if this one is big, this one is big, this is big, which has the biggest pain? Where can we start? That's what we are really interested in. And what we take a look at in each repository is something called technical density trends. So if we have 10 years of technical debt on a system, you should also consider the context of it. Maybe it's a very big system, then it makes sense that it has that much of technical debt. How we can normalize this and see and find the hotspots in rather repositories is normalize it, which is TD normalized by size. So we want to see per each line of code how much technical debt you have, and then you can have a better comparison. I'm gonna in the next few slides I'm gonna show you two components: their technical debt, their normalized technical debt, and also how we identified some problems that are stemming from somewhere else. So this is the first component that we have. In the first column here, you have the TD introduced in 2 weeks. Oh, and by the way, this is for 2 years. I think I forgot the legend here. The blue lines are for 2019. The red lines are for 2020. And each column here represents the amount of technical debt introduced or removed. If you take a closer look here, we have some stuff that are going down as well in the system. In the second one, we have the accumulated technical debt, which, as you can see, fast over the years. In the third column, we have the system size and how it's growing in the same years. But then what is important for us is the last one. So TD normalized by lines of code. And this is the trend that we are talking about. If we take a look at the blue line, even though the technical debt was rising a lot in the previous slide, you can see that the trend is coming down. So the proportion of technical that is being introduced in comparison to size is actually coming down. However, if you take a look at 2020, that is going up, which means that the size is not increasing. The TD is not increasing proportional to size. You have more TD that is accumulating in the relative size. Okay, so now this is a problem. Why should we have a system that last year was doing better? Now it is accumulating more TD. What we looked at was the composition of the teams and who was contributing to the repository. We have teams and the proportions that they contribute to the repository. But we found out that the owning team is relatively contributing less to that. So these this team owns the repository, but there are so many others who are actually contributing to that. In a way, the team works as a gatekeeper for the code reviews, right? So this is a correct identification. We confirmed this with the developers, and they were already aware of such a problem. So in a sense, we can identify where the pain is and where to start. Now I'm gonna show you a second component. Again, similarly, the same thing. Blue line is for 2019, red line is for 2020. The first column is the TD introduced per week, a relation of the TD years, the size, which is growing steadily. But the interesting part, again, what we are interested in is the trend lines. So now we look at this and we see that it's more or less horizontal. As the system grows, technical debt also grows more or less with the same pace. So it was it follows the same pattern over 2 years that it has been. It's okay. It's not a big issue. Then we apply the same contribution investigation on the same component as well. And here we see that the owning team actually contributes more to it. And that confirms for us that the previous component that we had suffered from the ownership problems. Okay, so now that we were able to identify the pain, where the pain is, we want to administer some solutions. It can be refactoring the architecture or reorganizing ownership, restructuring teams, more specifically in the previous case, or even just simply repaying some of the TD, right? And this is where the context specific comes from. You should know where the hotspot is, what is causing the pain, and then administrate the correct solution for it. So how we can do this in a practical sense is the data that we look at is the version control data, the history of what has been done, usually Git. We take a look at the Jira tickets issues that we have. And also we take a look at organization structure, the company documents, who works where, who talks to who, and such information. The tools that we use is SonarQube, which I am sure you are all aware of, and CodeMod for calculating some of the basic metrics that we have. So our approach is, again, to summarize, looking at the code and architecture using the information that we had, either from the Git, the static code analysis, also mirroring that to the organization to take a look at the affiliations and the communication patterns to be really able to spot the pain location. Our goal is to find the hotspots, address the problem there along the gain, and then evaluate our approach, and then repeat again. So now, Javier mentioned that we want to grow out of our technical debt terms that we are using right now, and more or less address the degradation and the propagation of the degradation. The examples that I provided for you are the things that we have already done, which involves architecture and organization. However, we are working to include other perspectives, such as requirements, tests, documentation, and you name it, to be able to really find, okay, if you have a requirement problem, you can fix it over there, and then your code technical debt will be remediated. And with that, I think I can finish talk here. Similar to what Alex has presented, we always look forward for new collaborations. If anybody's interested, you can just approach me or Javier. And yes, with that, I'd like to finish this presentation. Thank you.